I melted 50 different cheeses in a laboratory. The Australian ones did something weird, something that confused food scientists for years. Let me show you what happened. Melbourne, Australia, 2018. A pizza restaurant owner named Marco has a problem. His cheese won't melt properly. It just sits there, solid, stubborn, refusing to cooperate. He's using the same recipe his family used in Italy for generations, but something's different here.
Marco isn't alone. Across Australia, chefs are complaining.
Grilled cheese sandwiches that won't get gooey.
Lasagnas with rubbery cheese layers. Mac and cheese that stays chunky. It's not just one brand, it's everywhere. Australian cheese behaves differently, and nobody knows why. Here's what makes this strange. Australia produces excellent cheese, award-winning varieties. Their cheddar wins international competitions. Their brie is world-class. But when you try to melt it, that's when things get weird, especially compared to American cheese. In America, cheese melts beautifully, perfectly stretchy pizza cheese. Smooth nacho cheese sauce, that iconic cheese pull everyone loves. Australian cheese? Not so much. It splits, it gets greasy, it stays lumpy. Professional chefs are frustrated. Home cooks are confused. Enter Dr. James, a food scientist at the University of Melbourne. She's been studying dairy chemistry for 15 years. When complaints about Australian cheese start piling up, she decides to investigate. Her approach? Simple, scientific, methodical. Dr. John starts collecting cheese samples. Australian cheddar, American cheddar. Australian mozzarella, American mozzarella. 50 different varieties in total. She brings them all to her laboratory. Sets up controlled melt tests, identical conditions for every sample. Same temperature, same time, same everything. The first test is simple. Place cheese on a heated surface. Measure how it melts. Document what happens. American cheese samples, they melt smoothly. Create that perfect cheese pull. Become creamy and stretchy, exactly what you'd expect. Australian cheese? Something else entirely. The Australian cheese samples melt differently. They release oil. They separate into solids and liquids. They get grainy instead of smooth. It's consistent across almost every Australian sample. Dr. Chen has found the pattern, but she doesn't know the cause yet. She needs to go deeper. So she starts analyzing the cheese at a molecular level, looking at fat content, protein structure, moisture levels, pH balance. The answer she finds will surprise everyone. Dr. John's first discovery? The fat content is nearly identical. Australian and American cheese have the same amount of fat. That's not the problem. Protein levels? Also the same. Moisture? Similar. pH? Close enough. By all standard measurements, these cheeses should behave identically. Then she examines something most people never think about, the calcium content. Specifically, how calcium is distributed in the cheese, and that's where things get interesting. The Australian cheese has calcium bound differently, much more tightly integrated into the protein structure. Here's why that matters. Cheese is basically a protein network holding fat and water. When you heat cheese, the proteins need to relax and flow. Calcium affects how tightly those proteins stick together. More calcium, tighter bonds. Tighter bonds, less melting, more separation. But this creates a new question. Why does Australian cheese have more bound calcium? It's made using the same basic process as American cheese. Same equipment, same techniques, same cheese cultures. Dr. John needs to look even further back, to the source, the milk itself. She starts testing milk samples, Australian milk versus American milk, fresh from dairy farms, before any cheese making begins. And immediately she sees a difference. Australian milk has higher natural calcium levels, significantly higher, about 15% more on average. It's in the milk.
Now she needs to know why. What makes Australian cows produce higher calcium milk? Is it genetics, feed, climate?
Something else? She starts researching Australian dairy farming, talking to farmers, visiting farms, comparing practices between countries. The answer involves multiple factors. First, Australian dairy cows spend more time on pasture. Grass-fed versus grain-fed makes a difference. The grass has different mineral content.
Second, Australian soil is different, particularly high in certain minerals, including calcium.
That gets into the grass, into the cows, into the milk. Third, breed differences. Australia favors certain dairy breeds that naturally produce higher mineral milk. American farms use different breeds optimized for volume over mineral content. It's not one thing, it's everything together. The whole system produces different milk.
Dr. John publishes her findings. The dairy industry is shocked.
Nobody realized soil composition could affect cheese melting properties. It seems too simple, too fundamental. But the evidence is clear. Australian cheese melts differently because Australian soil is different. Not everyone believes her at first. Some cheesemakers are skeptical. Some farmers think it's coincidence. Some scientists want more proof. So Dr. Chen designs a new experiment, a more dramatic one. She'll make cheese from Australian milk and cheese from American milk in the same facility, same day, same everything, except the milk source. He partners with a cheesemaker in Melbourne. They import American milk powder, reconstitute it properly. Make one batch of cheese with Australian milk, another batch with American-sourced milk. Then they wait. Cheese needs time to age. Even a few weeks makes a difference. Dr. Chen documents everything. 6 weeks later, the cheese is ready. Dr. Chen sets up her melt test. Media is invited. Dairy industry representatives attend. Everyone wants to see if she's right. The moment of truth. The laboratory is packed, cameras rolling. Dr. Chen has 2 identical samples. Same cheese recipe, same aging. One made with Australian milk, one with American milk. She places them on heated surfaces, same temperature. Everyone leans in to watch. The cheese made from American milk starts melting smoothly. Gets stretchy, creates that perfect cheese pull, just like American cheese is supposed to. The cheese made from Australian milk begins separating. Oil pools form. It gets grainy. Exactly like Australian cheese normally behaves. The room erupts. She's proven it. The milk source determines melting behavior. Same recipe, same process, different results.